Hello everyone. I'm starting new video series showcasing end-to-end process how to release a game and publish it, and also include some advertisements. The target platform will be Android at the beginning, but using Unity allows us a lot of flexibility to create and just literally to change a platform later on. Our first game in the series will be, I call it Gravity Ball. And the goal of the game is actually to control the ball through the holes to the next level. The speed of the levels could be increasing, the size of the holes, it could be getting narrower. I leave this unique tools, what you want to create for each person decide. So everyone can create different own and unique game. So in this series, I just will be mainly showing basics, how to create, the main core behind the scenes, and all the sound effects and everything else. It's I left to you guys. As you can see, I'm controlling it using a mouse at the moment, but by the end of the series, we'll be using a gyroscope on the phone, and a player needs to tilt a phone to control the ball, and of course, and all points and not actually die. Okay, so let's get started. I'll be using a Unity 2022.1.4 F1 version. This is one of the newest Unity versions at a given time. And this is my settings, nothing special. I'm just using a template of 2D mobile game. As you saw from example, the game will be a full 2D platform. Pressing by create project. So here is a screen we can see after creating new project. So let's do some housekeeping, tasks before we even start. Everyone has their own preferable, of course, what's it called, layouts, but we need to do some key processes or key settings. So first, most important, if you're pressing Control Shift B, Control Shift B, we need to change our platform to Android. So switch platform. Okay. Cannot build the player while editor is importing assets. Okay, yeah. We're not building now, nothing. Okay. A second thing we need to do also is in the game page, we, instead of a free aspect, we'll be doing a 1080 portrait. So 1080 is still one of the most popular and most common resolution. And don't think about resolution itself. Think about ratio, because if it can be a 2K, but it still could be 16:9 resolution. We have this new 16:10 and all kind of variations of ratios, but our script will be concentrating on two main things. It will be physics, because the ball is bouncing around, and we want to make sure the ball is not skipping any platform because of speed. We know in the physics, if you don't do correctly, the ball can go through objects in a certain speed, because how we actually translating any game object. But that's a bit later. Another thing what we will be concentrating in our scripts is the script itself, a game, it must be adaptable for variations of screens. So we'll be writing and we'll taking a lot of attention to different screen ratios, different pixel sizes, DPI, and etc. So because all the platforms coming, we know how how much of a screen we want something, we know the areas, and that is really crucial for our script. Okay, going back to our main camera, one of the main things, I wanted to change our default background to black. So we'll be using a black screen and everything else will be in white. In our asset folder, we need to create a folder. Yes, a folder, and we just called a scripts. So in scripts, let's think what we want to start with. I think we can start with creating just a bouncing physics from a ball, and we take from there. Okay, so as I've just said, we need a ball. So right click, 3D object, and let's go with we should go 2D object, sprites, a circle. Yes, let's go with this one. I would like to go, I think, 0.1, 0.1. Sounds too small. 0.25 and 2.5. Looks still a bit too small, but I think it will be looking very good on a phone. Even though on this maybe it is a bit smaller. Let's rename this object to the ball, and we need to add few components. One of them is a collider, and it should be physics 2D circle collider. And if we zoom in, let's go back to the scene. If we zoom, okay, one more thing. I really not prefer that icons, so I can't see anything. I like the gizmos, I just don't like an icon. On this new version, yes, here is 3D icons. I just do 0, and so what we end up still with gizmos, but we don't have any icons in our way. So if we go and you see our ball, it has really nice green circle. So our ball now has a collision or a circle collider, but it does not have any physics. To do that, we go again back to physics 2D and we add a rigid body 2D. In here, my advice would be to leave dynamics as a body type. Material, we'll be addressing this one in a moment. What we need to make a change is collision detection. We need to make in continuous. Gravity scale, it will be a different story. We'll be addressing this one. You can address this one for your game mode. Maybe you have a ball in the moon, or a ball somewhere in the cosmos, and you would like to minimize this gravity. So it makes game much actually harder because any bounce takes longer time to go down. Okay, and if we start the game, you will see that our ball should just fall down. Yeah, nice. To collide with something, we need a platforms. One of the things I want to drag in is I created two images. One second. I created 2 images using a Photoshop. This is a white boxes, and I have left and right for a particular reason, and they are just 100 by 100 pixel white squares. That's all what I did. And in the folder, we create a new folder, images, and we can drag the 2 folders. It really doesn't matter. You can just go into Paint, open new file, and just save it as a white box, and it's really actually doesn't matter a lot. If you wanted to follow the same scale numbers, my advice would be to use any software you comfortable with, and just create 100 by 100 pixel, what's it called, a square. If you need something more details, I'm just showing now. It's a 300 dpi, what's it called, vertical, sorry, width and height, 300 dpi. Okay, so we just create a 2D to sprites. Yes, we do with square. We can use this square, but it is a reason why we not use, and the main reason of that is a pivot point. For your default square, and this more precisely square image, sprite square, you cannot change a pivot point, and this will be a crucial point later on. You will see. So what we do is let's call this white. Yeah, white. No, it's not white box. It's a platform left. Yeah, platform left, and we should have this one. Yes. So we drag our square, and it doesn't change nothing because it's exactly the same size as our default. The key point is when you click on your own imported image. Just want to double check I'm recording everything. Yes. When you click on that image, you can actually change your pivot point, and you change pivot point from center to the right. I know the object name is left side, but our pivot point must be on the right. Apply. And when you select that one, don't forget, please make sure your view is not center, but actually pivot, so you can actually see where is the pivot point. This allows us, now we know where it is an edge of the left platform. Scale should be going something like 0.25, I believe. Let me double check. 0.2 is more than enough. 0.2, and scale and Y we can do 10 at the moment. So you see what I'm talking about. This is a screen this is a phone screen, will be different per device, and we will be moving left and right accordingly, generating a gap between two platforms. Okay, for ball to collide with this, we need to add one component. It's a physics, and it's just box collider. Make sure you don't mark it as a trigger, because trigger just allows rigid body to go through, calling some event. For us, we don't want to have a ball go through this platform. We want to actually collide with that. So make sure this trigger is not selected. Okay, let's have a test. And our ball actually should hit. Yes, it hit, but as you can see, it did not bounce it. To do that one, let's go back to assets, right click, create physics, 2D physics actually, 2D physics material 2D. And let's call it, instead of new, bouncing physics, bouncing physics material 2D. And if you select that, you can see you can have two options. You have a friction and you have a bounciness. What I found by testing, 0.8 is one of the best numbers at a given time. Before we go with 0.8 or any number you want to do, my advice would be very simple. First, to leave it as 1 and do the very small test. You can see my ball is in the middle of this screen, which one is 0, 0. We launch the game. It should bounce. Oh, sorry, we forgot to add the bouncing material. So select the ball again, and we have rigid body 2D, and you have material. Drag that just material we just created into it. Press play again. As you can see, our ball is bouncing. Now, do a very small test. Zoom in your area where you had 0, 0. Make sure your ball is not bouncing higher and higher and higher and higher. It could be caused by various reasons. One of them is if your collision detection is discrete. I think if we make it discrete, yes, you can see it goes. It's already higher, and it keep going. It will be keep going higher and higher. So make sure it is continuous. So it should be doing the same height where we started with. Well, where I turn off. And it could be something to do with the engine settings also. I found that people adjusting this by lowering down this number. In our game, we will be using lower number anyways. So it could be not a problem, but it's still very good test to do before we're going forward, okay? So I'll go with 0.8. I find this number very playable and very fun to control the ball around. Okay. To test it even more, how it works, let's grab and duplicate a few more of them, and let's make some fun. Let's make it something like this, and let's grab another one. Yeah, this one. Somewhere maybe here. Yep. And last one, maybe something like. Yeah. And let's grab a ball. Just put it here, and let's see how it looks. So as you can see, all the bouncing of a ball is done. So what we need to do is it's two small things. One of the things is to make a boundaries. The boundaries must be adjustable, or it must be built at runtime. So what I'm trying to say is, if we start using something like this, and we put in the side like that, a different phone. If you go in a game view, let's drag a bit. Well, if you go in a game view, you see we can see a part of that how to say a wall, side wall. In another phone, it could be not even visible, or it could be in somewhere like 20% of your screen. So all this, what's it called? A frame we will build at runtime, and it will be actually adjustable. It adjusts itself per screen resolution, per ratio. Okay, so. In the scripts, let's create a new script. Let's call it a platform manager. Let's create a few more things. First of all, we need to create an empty. Let's go back to. Let's create an empty. Let's create an empty game object and call platforms. Platforms. Yes. And the reason of this object, put 0, 0, 0, the main goal of this platforms game object will be just to work as a parent. So every platforms we spawn in our game will be under this platform's parent. Okay, so even now we can drag them in and say just it is a platform. Next, also, I would like to create another game empty object where we call manager. So this is a game object where we put all our managing scripts in one place. If a script doesn't require us to be attached to a certain object just to do some job, we'll be adding to the manager. If a script actually needs to be attached to game objects, etc., ball, then we attach to the ball. Okay. So in our case, actually, platform manager straight away can go and be attached here. Let's open script. Okay. So we will need some variables at the beginning. So public variable float will be a number where we want a gap to be random. So we want a minimum gap size. What size of a gap could be the smallest one, and of course we need a max gap also. So we will be setting up min gap and a max gap in our editor, or it could be adjusted by the level you are in. Maybe it could be adjust itself by longer the game goes. Again, guys, I'll leave this one to you. Public float distance. Sorry, float. I said this distance. Jesus Christ. Distance, and this variable will define what is the distance between the platforms. So because you can actually make the platforms very close to each other, or make bigger gaps, and again this really varies per game, per situation, or per what you think is the best for a player. Of course, public float speed, so how fast platforms go up, and this will be private, so float falling speed. Okay, and I can't remember exactly why this is. Will come later on. So falling speed, we need to make it by default should be 0 f. Okay. What additional to all the settings, we need some game objects. We definitely need a game object of a ball. We definitely need a public game object. Left platform prefab. Yep. And a right platform prefab. Okay. What else we need? We definitely need a public game. Oh, sorry. Public game object platform parent. So we need that, and yeah, we'll need 4 more objects to be able to build the walls around. So we need a left wall, right wall, and we need a top wall, and of course we need a bottom wall. Okay. To achieve all the calculations, and as I mentioned at the beginning, we really need to make a lot of attention to our screen. So we need a float screen width and screen height. Okay, we need both this. We need a public vector 2. So we have a screen X and screen Y. Y vector 2. So screen X will have screen X sorry, no, sorry, I do apologize. Screen min and a screen max. Okay, so screen min, it will have X and Y variables in the vector 2. So screen min showcase a lot. You can say the bottom left corner. It is what the screen minimum is in X, and what is the screen max in X. What screen minimum is in Y, and screen max in Y. So we using these two variables in the vector 2, we can get all four variables, or you know, what's it called, numbers. One thing I want to showcase also, because it does has a reason why it is public, and the reason is to be visible and shareable between scripts, but we don't want to access to this via editor. So in Unity, you can use square brackets and you can write hide in inspector. So then you put this declaration before any variables. Even though they are public, they will be not visible in editor. Okay. We need, we need a float. We need platform start, and of course platform end. These two variables will be defining where we start throwing our platforms, and is a location where we're destroying them, or in our case will be moving up. So you can imagine this platform goes up, it goes above the screen, it reaches some height. Well, we can define here, and after reaching that location, it will be moved back to the bottom of the screen, if it makes sense. Okay. What else we need? We need to track how many platforms. Platform. Now, what's it called? Number of platforms. We need to track how many platforms we do have, and we need also to float to track a falling trigger. Yeah, you can imagine that the ball is falling through the gaps, and let's assume the ball is, the player is so lucky he is hitting 10 gaps, you know, in a row. Yeah, 1 second. And if we not speed up all the platforms to start flying from a bottom, the ball actually just fall down or fall below the screen. So we need a height, which one we call a falling trigger. When the ball reaches the bottom of the screen, we actually take this, a trigger, and we execute some certain actions. Stay with me, and you will understand more in detail when we start approaching this variable. Okay, one additional thing what we need also is a custom class. We can create a separate script file. You know what? Let's do it in a separate script file actually. So let's call it create new C# and let's call it platform. Yeah, just a single platform. Okay, the platform will be not coming from mono behavior, and it will not have void or start or update. It is just a custom class, which one we're creating for a reason. So how to explain this? A platform class will be as you can imagine like a bucket of all the variables. So instead of we defining all that variables for each platform in a certain array or maybe a list, and you try to link them together from one bucket to another bucket. What instead of that, you can create a custom class. A custom class because it's not a class from mono behavior or a class from Unity libraries. You're just creating your own class with some certain functionalities, and you'll be reusing it in our platform manager. So this class and platform, you can imagine, by the way, the platform you can imagine that as a one game object with all the variables. A lot of people actually creating this. A lot of developers, put it this way, is creating a class for a player, for enemies, etc., etc. So in our case, we'll be creating this class for just a platform. So the platform should have a few, how to say, not few, just actually at a given time, just a public variable, and that will be game object. And it will be left, and it will be right. Okay. A class, our class will have defined constructor. So it must be public, no void, nothing. You just give this. It's a function. You're giving the same name as the class itself. So when you will be defining the class, you're saying, okay, this class platform, you give a name, and this will be equal new class. That called construction. By default, you just call it and happy days. Something between like, if we save it, yeah. Let's go back. Yeah. If we save, we go in a platform manager. We say platform, and we give a name, platform unique, platform A, etc. We just gave a name. Yep, is equal to new platform. Yeah, that's how you normally do. Very simple. But we don't want to use default platform. We want to actually ask ourselves, when we're creating a platform, to pass some variables. In our case, in a platform, we wanted to pass game object, left platform, and game object, right platform. What we want to do with these variables, we want to say that our left is equal to left platform and the right is right platform. Actually, I very like this new Visual Studio. The AI they're implementing to suggest what I'm trying to type. It's getting better and better every day. I don't know, it's learning to adapt to me, or just updates is coming out. It's really great, actually. Okay, let's go back. So now you can see that I'm creating a platform A, which one is a type of a platform, and I'm defining as a new platform. It gives me an error saying, okay, you cannot just create platform A. To do that, if you wanted to create platform A, you need to pass left platform and the right platform. Okay, so, okay, I'm got it, but we'll do this later. We'll come back to the platform object, sorry, platform class a bit later. I wanted to concentrate on this first. So for all the platforms, because we don't know how many we want, and the mainly reason is this. Maybe you want to, how to explain it? Maybe one of the developers thinks that this gap is acceptable, and I want to play the very high bouncing, low gravity, special room. And in that case, you will be end up with maybe 1, 2, 3, 4, about 5, maybe 5 platforms, to cover all your screen. But another player or another developer thinks that this gap is best. and this possibly could be about 10 platforms. So we cannot say how many platforms we need to cover our screen and above and below also. To achieve such thing, we will be using list instead of array, and the list is very dynamic. That's one of a great thing. So what I'm trying to say dynamic, it don't have defined size. It's same as array, or you can say it's similar as array. And let's not get too much technical. It's similar like array. It has you can get all what's it called, members by passing ID or a sequence number, but it don't need to define how big list is. List type will be list. This list will be holding platforms, and the name will be platforms equal to new list of platforms. So we don't forget to do this. If you forget that one to do, you get some errors when you start playing a game. And this is crucial because it actually allocates in our memory this list, allowing us to add more members into this list. At the moment, this list is empty. But if you don't define it as a new list, and later on you'll try to add something, it will be causing some problems. You need to create this list, so it allocates some memory in your RAM, and then it allows you to add some members in it. Okay, let's get into our start function. And our start function is really simple. Well, saying simple, we need a screen. Let's go with a screen width. Yeah, screen width is really simple. It's just screen.width, and a screen height is a screen height. Yeah, we can also debug log saying that screen size space W space or dash, put dash, yeah, let's put dash plus screen width plus space h dash plus screen h. Yeah, so what it does, it's why you need some special dash, space, because when this number will be printed, you wanted to leave it some gap. These gaps around plus doesn't count. You need to actually put some spaces in string to keep it gap between, variable this and variable that, etc. Okay. Okay, and now we need two functions. One of them, let's call. Let's do one at a time. Get screen location. Oh, Jesus Christ! It should do void get screen location. Okay. Get screen location, and the purpose of that one is, one second. Okay, so what I mean by saying get screen location. So this is like location in the 3D world space. If you have a look at this one, I would like to showcase, maybe it gives you a bit more understanding. So if I go this one to 0 and 0 and 0, the ball suddenly became in the center of the screen. Our screen, we know if we go in a game, it's in 1920 by 1080. So let's concentrate about 1080. Yeah. So in 1080, our ball is in the middle. So that will be 540, but that's 0, 0, 0. And if I go in X, which one will be 0, and this will be 0 here, let's assume that should be 0, 0 for a screen resolution. but it's actually, it is minus 2.8 and minus 5. So as you can see, our 3D world space location of a ball is actually different for our screen pixel number. So 1080, it doesn't match with our, world position. And if I'm not mistaken, Unity is using meters. So by saying minus 5, it's a 5 meters down. In screen, that would be 1920, or in exactly this location would be 0, and that will be 1920. Okay, if that makes sense, I hope it makes sense. This is what we try to achieve. We know screen resolution, we know the screen width. We can even make a note 1080. 1080, and we know a height, which one is 1920. Now we need to know how much we actually have a location, 3D location. To achieve that one, we need to do a camera. Lower camera min. We definitely do have a camera min. Screen min, and okay. Let's change this one. It's more like camera. Camera min and camera max. That makes more sense in my head. Okay, so camera min is equal to a camera dot main dot screen to world point. And that is where we have to pass a vector 3 of the screen, and we will get a world position. So screen to world. So now of case would be if I pass 0, 0, it should be 2.8 and minus 5. It should be for my screen. If someone plays this game on a different resolution or different screen, it could be even here. It could be about maybe here, if a smaller screen, or maybe different ratio, maybe somewhere here. So these numbers are moving around now. If you can see in editor, this left corner will be different for person to person or phone to phone. Yep. So minus 2.8 in my case, and minus 5. On PC, should not be changing quite a lot, and especially while we are in an editor, because we set a certain screen resolution, 1080 portrait, and it's not changing. So to achieve that one, okay, I already said. So we need a screen. Yes, we do go vector 3, and left corner. Left corner is really simple. It's a 0, 0. So what we do is 0.0. And of course we need this z, so we need still add another 0 for a z axis. And that should deliver us a camera. Well, we will be debugging this one, but it should be delivering these numbers, minus 2.8 and 5. Okay, so how about another corner? How we can get 2.8 and 5? So this corner, let's move you away. So we need to find this corner. It's the same line, but we just need to do a bit different. Instead of min, it will be max, and it's instead of 0 for x, it will be a screen width and a screen height. So screen width will be 1080, height will be 1920, and the ball appears here. This what should be returned, 2.85. Okay, so to see that, we'll be debug.log. Let's print that information. So world to space world to space, and we leave 2 maybe gaps. So min is 1 space and plus camera min plus space max comma space camera max. So now we can see what it returns. So have a really quick. Let's have a really quick Let's open console and let's have a really quick test. So, yep. Okay. The thing is that we created that function, but we never call it. So get screen location should be happening somewhere here in start. Yeah. Don't when you're creating the function, don't forget to call it. Okay, so now, yeah, and let's pause the game. So now you can see that width is 1080, height is 1920, and world to space minimum is minus 2.81 actually, and maximum is 5. Sorry, minimum X, minimum Y, maximum X, maximum Y. I'm a bit surprised it's 2.81, but yeah, my OCD just a bit killing now. Okay, following, what else we need to do? Next thing we need to do is actually generate platforms. So this will be a bit task void generate platforms. Okay. So at the beginning of generation of platforms, I believe that would be really great that we start with our, what's it called? With our left, right, bottom walls, etc., etc. So it will be, let's you know what? Let's generate platforms, generate walls instead of platforms. And for that one, we know that left wall. That's the one. Left wall. Okay. So left wall has a pivot point on the right side. And let's have a look. So this is, by the way, all this is the left ones, if you can see in here. So let's delete all that ones. So left platform has here. So we need to do go back to 1. Okay. First of all, stop again. Let's delete this ones. Before even we going further away, let's go back to, we created platform left. We never created platform right. So let's Control D and duplicate. And instead of left, let's call it right. Okay. Let's raise it up. And in the right, let's drag another image. Which one is right? You can see now straight away. Let's remove the box collider because you can see it does not line up anymore. And when you click on the white box right, let's change a pivot point from the center to the left and apply. Okay. If you select the object, you can see now the pivot point is here and it goes this direction. If you select that one, it goes that direction. For platforms, going back to assets, right click, create folder, and let's call it a prefabs. Okay. Sorry. So platform left and right, let's drag one by one in our prefabs folder. So we have a prefabs now. Now we can actually delete them from the scene. You have 2 prefabs and a ball in the corner, actually. Let's go that one in the middle. So now we need left and right. We can drag them back in the platforms twice. And I need you one more time. So we have this. What I need to do is, what I want to do is to select all of them, right click, prefab, unpack completely. So they don't have a link anymore with this prefabs. And the reason is because we will be using this ones as not a platform, but as a walls. Yeah, before we're doing that one more thing. Let's delete them again. Scale it back to 1 left, and scale back 1 to 1 right. Okay, let's drag them again into platforms. Oh, no. Okay, and select again them, prefabs, unpack completely. And the reason is because we will be using them as walls. So it will be wall left, wall right, wall top, and the wall bottom. Okay. We have all 4 walls. Actually, if you click on the manager, you can see all this stuff. And we have left wall, so we can drag that one. We have right wall. We have top wall, and we have a bottom wall. Okay. Left wall, I need to rotate 90 degrees. I would like to put you somewhere about -3 and a -5, somewhere in that corner. So it's, it's ready to grow. Just for this, what I'm doing is purely just for, his ability to see where everything goes in. The right one, we want to maybe rotate another also 90 degrees, -90 degrees. No, just 90 degrees also. And we want to put you maybe in a 3 and a -5. Okay. Yeah, it doesn't do that way. It maybe puts in 5, so it's ready to grow also. Top one, it's the right one. Actually, top one and a bottom could be left and left. We don't need to right and left. It could be all the lefts ones. I'm just thinking now. Yes, it could be. Yes, for simplicity, let's make it all the left ones. So wall left, Control D, 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 yeah, and rename it. Right, top, bottom. Okay, -3. Let's make it 3. Top one, let's make it a 90 degrees back. Yeah, let's make it 5. Top one. Oh, 5, maybe 5.2, something like this, or 5.5. 5.2 makes more sense. And the bottom one is just 0, and it's -5.2. Okay. Yeah, also, oh yeah, top one could be a 0 and bottom could be 0. So we know now that we need to use these 4 walls, and they need to adjust its location and the length to cover and build a box around our area we can see from the phone screen. Putting in the locations, it's kind of easy to do. So generate walls, we going with left wall is left wall dot transform dot position is equal to new vector 3. And what vector 3 we want? It's a left one, so we definitely want a to go in a camera min camera min.x. Camera min.x is x has in a camera min.x is this side. Camera max.x is this side. So we want this corner. So it will be camera min.x, and we want a camera min.y. The thing is with y, we want because the walls is really straightforward. We want a be on line, but with a bottom and the top lines, we want to give a bit of gap for a ball allowed to fall in or go up, so it will be causing some winning or losing conditions. So for a camera, because we're going below, we need to subtract another 1 meter. And z, as always, is 0 as we're working with 2D. We can go with vector 2s, but my advice would be go with vector 3s, get used to the z, and that will be this life will be much easier for you later on to to go from 2D to 3D games. Another reason is also using vector 3s allows you to put or define which object must be drawn on the top of another. So because if the two platforms or something else is drawing in the same location, I know like a ball should be always in the front. So I can do as a z as 1 or a -1. I can't remember exactly which direction you go, but I believe it's 1. So I know that the ball will be drawn over time on the top of the platforms if I do this one. So of course we no need for this use cases because the platform should bounce the ball, etc., etc. But depending how you want to colorify your game or make unique, vector 3 could help you to defining this drawing order. We're not talking about Canvas. Canvas has this functionality for UI. That's a totally different thing. We're working with game objects, and vector 3 is a good option to define this order. Okay, 0. Okay, and that's it. That's really simple. Now let's go with the right wall. Right wall dot transform dot position is equal to new vector vector 3, and which will be camera. This time we go camera max.x because it's on the right side, but still bottom. So camera min.y -1, so 1 meter below screen, and just 0. Okay. Camera max, camera. Is it? Oh, I will be extending down. Sorry, guys. So this should not go in this corner because I'll be extending down. So what I mean by this saying, look, if I'm extending, it's extending down. So instead of I'm going in this corner, I actually need to go in this corner. So instead of min, put max.y, and here max.y. Okay, and instead of minus, we need a plus and extra plus. Now, bottom wall dot transform dot position is equal to new vector 3. In this case, we want a bottom wall to go camera max, I believe. No, sorry, no. Min and x. Let's think again of this one. So a bottom one need to go in this corner and goes this direction. So it needs to go here somewhere. Okay, so let's go in the camera not min max.x plus 1, why not? And location needs to be a camera min dot y minus 1 0, and a top wall dot transform dot position is equal new vector 3 camera again max dot x plus 1, and it must be a top, so camera max dot y plus 1 set a comma 0. Okay, generate walls. Let's do generate walls, and we have all that ones. So what it should do now, what it should do is, doesn't matter where they are, it should go in the corner. So these two bottoms should go slightly above this angle, and this two should go slightly above, well, more right than this wall. Okay, can't see. Okay. Oh yeah, we did not sign up them manager because we delete them and we reinserted them. The editor lost references to this object. Let's try again. Yeah. So they are slightly above and they are slightly more right. So exactly by 1, and their base size is 1. Nice. Okay, so we know the corners. What we need to do now is to actually know how many what's it called, a scale we need to do. Okay. And to do that one is really simple. Left wall dot transform dot local scale is equal to new vector 3, and this is where magic will come. So we should have three, what's it called, three variables. We know that z will be 0. That's 1. In scale, it's always 1. For x, the left is going this side. Okay, for y, we know that it should stay the same as it is. So we're saying left wall dot transform dot local scale dot y. So wherever it is set in editor, keep it the same. So we don't need to come here and change it. But this will be a bit magic. So we in the brackets. Let's start from brackets. In the brackets, we know that it will be camera max. So we can go, yeah, camera max, and the left goes up. So camera max dot y multiply by 2, because camera max is actually only stating the distance from 0 up. So if we wanted to know all the line, so because what it is, we can do 2 ways. We can do camera max dot y, so it'll be this half, so from here to here, yeah, plus camera min dot y, so it'll be this distance. But because by default, how we just write all the code, we know that both sides is equal. So instead of camera max dot y plus camera min dot y, we just do camera max dot y multiplied by 2, and that gives you 1/2 and another half. So we just find out the full width, well, height in this case, of the screen. in world's units. Okay, and plus 2. And the reason plus 2 is because we want a one unit extra here and 1 unit extra there. Okay, if we just save it, just the left one, we can actually test it. Okay, and it did not happen. No errors also. Okay, let's double check. Left wall transform dot local scale is new vector free camera max dot y multiply by 2. Left wall transform generate walls local scale camera max dot y multiply by 2 plus 2 semicolon left wall transform local scale dot y and yeah, left wall and oh, we need to actually save it. Yeah, that's a good one. Okay. Yes. So we as you can see, we just build a left wall, giving by extra 1 unit below screen and above the screen. And because we're doing with the screen, we can see a half of our wall in the screen. Okay. So we just need to repeat now the same with right and left. So right wall transform scale will be same, except we need to change here also. Yep. Now top wall, it will be a bit different. In top wall, we need to say that actually X scale. Top wall. No, it's still the same. Is it? Yeah, it's still the same. Sorry guys, I think it's still the same because we rotated 90 degrees, so it's still X. You just because it's rotated, it takes a different, but because it's a local scale, it does not apply how we rotate the object. So it's still, we're still scaling at X. And let's have a quick test. Okay. Yeah, we still need to do one thing. It is not a Y anymore, it is X. Because we just applied a height to a width. We just need to X here, and let's have a look. Okay, so this is how we just build using script a modular frame. This frame is matching our side walls and gives at least 1 meter above and below a screen, allowing allowing to, what's it called, to call some events. Maybe below the screen, you need to speed up and get ball back, or maybe it's maybe in your game it's a winning condition to just get below a screen. If it goes above the screen, that could be a losing condition. So yeah, depending game, depending rules you want to amplify, this could be helping to you. I think later on we'll be removing the bottom and top ones when we have the platforms rolling up and down, and we will be start playing with the what's it called, triggers. That's really simple to do is that we select the bottom wall, and we just, as I mentioned before, we just select trigger, and also we can remove a sprite. We don't need the sprite, we just need this trigger box. And if I press play again and we go back to scene, yeah, you can see it's no more a platform, it's just a trigger area. So because anyways it goes below a screen, we don't want it bounce back into screen. We want to know that the ball reached this area and we call game over, etc., etc. So the same applies above. Okay, so I think this is where we can wrap up the first episode from the series. Please leave some comments. I have not defined it yet or find it how detailed or technical I need to go with this tutorial. So far we have done very minimal coding. I think this is not, it's not very, how to say, a basic beginner's tutorial to explaining what's his local scale and what's his position or local position, and something like C# things, or how we can use the debug log. I'm expecting the viewer, the basics of Unity, and this is just a guidance towards end-to-end process, because most of the times when you go into some tutorials, they're showing a certain aspect, but I was a bit struggling to find a good tutorial, a person who has recorded from beginning, from scratch up to a full working game in App Store, delivering some money to developer. Okay, so see you soon then.